I took a screenshot and sent it to Yonatan, and he said, no rhetorical questions allowed. And then I said, okay, I'll consider this a 1-0 for me.
In this exclusive episode, Ankit sat down with Elliot to discuss his work with Yonatan on oracles.
The goal is to design a game and have that game implemented at the miner level.
Blockchains are isolated from the outside world to prevent tampering and ensure consensus among nodes. However, this isolation creates limitation as smart contracts can't natively access real-time external data. This is where oracles come in.
Even if you have 1,000 nodes fetching data, if they all fetch from Binance, you have no decentralized oracle.
But today's Oracle solutions grapple with the centralization risks.
I manipulated the data so people lose trust in the Oracle and the L1 token falls in price. So this is the security argument from the founder of why the Oracle is secure, which makes no sense. If you manage to embed it into the layer 1, it'll be probably as I'm aware, the first time it's done, and I'm kind of looking forward to that, yeah.
Supported by Kaspa.com, the leading Kaspa DeFi with DEX and lending. Igra Labs, atomic programmability on a Kaspa block DAG. Kaspa Finance, the first V3 DeFi protocol on Kaspa.
Today I'm here with Elliot. Hi Elliot, good to see you again.
Hi Ankit, thank you for having me back. Good to see you.
Awesome. Look, Elliot, I wanted to have you over to discuss your work with Yonatan on oracles. But before we get on to oracles, I wanted to quickly ask you, how was the Kaspa transparency event over the weekend?
Yeah, it was great. I'm very grateful that Ashton invited me to speak there. Brought along my cousin and my friend, who I hope later on will be able to contribute to the ecosystem. Was glad to meet a lot of people, the eager founders, Christian Ludwig, which I'd been wanting to meet for a while, Chris, and obviously Ashton. So it was great talking with everyone and finally getting to meet them in person.
Yeah, I saw some photos. We couldn't go ourselves, but yeah, it looked like a very good event. And I wanted to quickly give a shout out to Ashton and Natural Nacho team for organizing the event. Anything stood out like specifically to you that is worth looking at for people that weren't there?
I mean, I was pretty impressed to see so many builders already present, given smart contracts aren't here yet. So that was very nice. The KNS domain founders were also incredibly nice guys. Their first time in Europe, so to see how determined some people are to attend these events, and so many people before any smart contract is truly amazing. So yeah, I'm just looking forward to all the apps that are going to be built on Kaspa.
Oh, beautiful. I'm quite surprised to hear about KNS domain guys, because I think Christian, when we had him on the podcast, he said they are not doxed. So it seems like they did dox themselves.
Yeah.
Awesome. So let's quickly get into the topic then, the topic at hand today. Let's quickly establish the base first. So what I wanted to ask you is, what really are oracles and why some blockchains can't work without oracles?
So oracles essentially are a way to get off-chain data onto the ledger. Every blockchain is an isolated ledger which doesn't have access to whatever's happening around it, and there has to be a way, if you want to build DeFi, if you want to build lending and finance, if you want to build finance on top of a blockchain, you need access to everything that's going on around. You need a way to determine the price of that asset relative to something else. So for example, CAS on USDT, and any centralized exchange, whatever is going on Binance is not cannot be found on the blockchain. So you need something to give that external price to the ledger.
Right. So these are, as you say, isolated, like blockchains are working as isolated systems, right? And they're really designed to be operating as a trustless, decentralized in the trustless, decentralized environment, right? And I think the part perhaps also we don't often talk about is that blockchains are deterministic in nature. I think within the developer community, they will know that, but that's a key component here, that deterministic nature. That means they don't have access to outside data, right? They're operating within themselves, right? And I think that's the part what oracles really feel, right, to bring the external data. Is it a fair statement?
Yeah, it's a fair statement. And you can have a great blockchain, but if you want to build DeFi onto it, essentially you're going to need an oracle. And if your oracle isn't good enough, it's going to be the weak link in your DeFi system. So whatever you're going to build on top is going to need an oracle as basically the foundation. If it's not done well, it can lead either to having trusted systems, which is not what decentralization is about, or it can lead to failures if the permissionless system is not designed well enough.
Yeah. Yeah. Also, just quickly, what are the differences between different blockchains that can access oracles and some can't access oracles? Like Kaspa, being the non-Turing complete, it cannot actually access oracles, right? But certain blockchains can. What is the difference? Have you looked at it?
So you mean, yeah, can you elaborate a bit?
Yeah, like for example, Kaspa on layer one directly, we can't have oracles, right? But on Ethereum, layer one was designed to have oracles essentially.
Oh yeah, okay. So the smart contract design in the
Right,
in the
right,
system.
right. Smart contract, but also the type of, I guess, the infrastructures built, right? Which is what I'm saying is non-Turing complete versus Turing complete, right? Kaspa isn't one versus Ethereum is.
Yeah.
So I guess I wanted to clarify that it's, on the layer one, on the Kaspa layer one, we can't have Oracle sending data to, because there is no infrastructure there.
Yeah. I think probably vprogs are going to play a central role in that. I don't have too much of an understanding on how, if I design a solution, how exactly it's going to be implemented. I think Yonatan has that vision and for now wants me to concentrate on actually having the solution. But from what I've taken, the goal is to design a game and have that game implemented at the miner level. So having the miners on the network participate in the Oracle game, which means that even at 10 BPS, you've got 10 different players each second, and there's competition for the Oracle game, and you benefit from the decentralization, the cyber resistance of having to set up a miner, which is no easy task. So if you manage to embed it into the layer one, it'll be probably as I'm aware, the first time it's done, and I'm kind of looking forward to that. Yeah.
Can I ask then, what exactly is your work, or what exactly you're focused on? For now, the way I understand it, these oracles, all the work you're doing perhaps is more of a research based, but in reality, oracles will be used on the layer twos, right? Across Casplex dApps and IGRA dApps.
So yeah, the way I see it is, however you implement the oracle, the theoretical foundation needs to be solid if you want all this finance to be built on top of it, all this money to be secured by it. So my work is purely academic. So basically, when you read a white paper, you've if it's done correctly, like GhostAg, for example, it takes quite a bit of research, quite a bit of proving everything, coming up with the theorems. My work is to design a game, an Oracle game, where the optimal strategy of any player is to report his honest belief on what the price is. So, because if oracles are to be really trustless, then you should be able to ask anyone to participate, namely the miners. And given they have an incentive to lie because the more your oracle is wrong, the more they can profit through arbitrage, unfair liquidations, all that. They have an incentive to lie. So you need to design a game where it's economically ridiculous to lie, because you'll lose way more money than you can profit.
Right. Is it the tasks that were given to you?
Yeah.
Really?
I mean, the first, at the start, the goal was looking at academic papers, because we were pretty convinced that this already existed, or at least an estimator that could function with observations that are malicious.
Mm.
We thought it was obvious. There was no way nobody had done that, and pretty deceiving to see that it doesn't exist. Statistics are like, statistical estimators are a big thing. They're widely studied, but generally you have observations from a certain distribution and you're not questioning if they come from that distribution. You're trying to estimate a parameter of that distribution as well as you can, the mean, the variance, whatever you want, but you never question the distribution itself. And so this malicious model where you have a certain percentage which are giving you false data, it only appeared in a model from Huber. And the problem is there's too many differences. These malicious actors don't adapt, they don't collude. It's just they're taking their observations from a different distribution. And he basically said that the best thing to do is take the median, which I think is why everyone is using the median, but the model is far from how it should be. It's not as detailed. So yeah, my goal is to make that paper.
Right. Huber. Is it the name you use? Huber.
Huber, yeah. Huber.
Okay, so is that a paper that you're referencing here, right?
Yeah, it's it's a mathematician who had a very significant paper in statistics, which are M estimators, and yeah, his paper is very good foundation, and it's very, very cited. I studied it in statistic classes, but
Okay.
yeah, it's just not as like, the model needs to be adapted if you want to take it into account in an Oracle games. So yeah, oracles are going to be a thing before there's a perfect solution, and it's pretty scary to see how these how oracles are going to be implemented. So I think if you look at Chainlink, it's not bad per se. It's trusted, but it still hasn't had failures, which is a good thing. So you can still implement an oracle without it being perfect. It's pretty scary when there's low liquidity, but there are ways to design something even better than Chainlink currently. So that's my goal with Cascade, is to design the best possible oracle, but before having an oracle that's implemented in the layer 1. So it would be more traditional, but try to make it more decentralized.
So what are the issues that you've come across within oracles? I think you've highlighted before, but let's break it down. Specifically, let's focus on Chainlink being the biggest protocol that we have. Well, what are the issues surrounding Chainlink that you've come across?
So the main issue that a lot of people fail to, it's badly communicated, which is intentional, but how Chainlink works is it has a set of nodes for certain price feeds, say Bitcoin. So it has 10 nodes, and these 10 nodes are tasked to go fetch data from wherever they want, essentially. And once they fetch data, they sign the data saying, okay, you cannot prove cryptographically where this data came from, but it's mine. So I prove cryptographically that I have sent this data, and then you aggregate it using the median, or Chainlink uses a median, and that's your price. So you have these 10 nodes fetching data. You don't know where the data comes from, but you've got a price. And the problem with this is if the 10 nodes end up fetching the data from Binance, essentially you're just pushing the price of Binance on chain, and there is no decentralization. So there's this false narrative of we have 10 nodes, which 10 is not a lot. But even if you have 1,000 nodes fetching data, if they all fetch from Binance, you have no decentralized oracle. So that's the problem when the signing of the data comes from the nodes, not from the source. Because basically you're aggregating, but you don't know what you're aggregating. There's this false idea of decentralization just because a lot of people are fetching the price. But if they're all fetching from the same spot, then it won't matter.
Yeah. It's I think, I want to define this issue because perhaps from my understanding, this is the core of your research, right? So can we just define how Chainlink goes through fetching the data and then sending the data to the blockchain?
So each node fetches any price. They could just come up with a price. They could write it down on a paper and say, this is my price, but they're going to go fetch it through an API in general. And once they've fetched it, it's pretty simple. All you have now is the median, and you've aggregated different prices. You end up having one single entity who pushes it. I mean, it's on Ethereum, so any single leader consensus, you're going to end up trusting one person to push the price on chain, which is the node, the leader of this round. So if that validator, if that node has an incentive to censor the data, for example, or to lie, I mean, they could be slashed in a proof of stake, but if there is a huge incentive to create a false oracle price, they will do it. And you can have a perfect oracle fetching a lot of different data sources with a lot of different nodes, having a magnificent aggregation. But if you end up trusting one person to put it on chain, then they can censor it as much as they want, which is a nice thing if you manage to implement it on the Kaspa layer 1, because you've got these parallel miners who are all pushing at the same time, and censoring becomes very difficult. It's the same reason why MEV is harder on Kaspa than it would be on Solana or Ethereum.
I love Chainlink, but there are certain things I felt for a long time that they've over-engineered, right? I think without actually thinking through the problem, as you said, right? They fetch the data. Okay, well, first issue is where the data is coming from. Secondly, right, they have this thing which is they choose a leader for that round, and then all the nodes that are participating. So it looks like it's a decentralized process because they establish a quorum, and then the quorum sends, all the nodes in the quorum sends all the data as observation to the leader. Then the leader packets it, creates a median value, removes the outliers, which kind of, I don't know, is interesting. And then it signs it cryptographically and then sends the data to the blockchain that's asking for it, requesting it, right? That's a very interesting process, and it makes sense, but it opens up to a lot of trade-offs, right? A lot of inherent issues for me, right? And some of the ones you've already defined. So the first one is, even if all of them are decentralized nodes, they all could be relying on single source of data, which is what you mentioned, right? So that could be Binance for the price of Kaspa, right? So it could have 100 nodes. They could all be relying on the same source of data, right? Then the second one is the data manipulation itself, right? Data manipulation by the source. So it might not be the Binance, it might be the market maker behind it that can manipulate it, right? How do you solve that problem? Because that's a big problem for me. So even if they're all decentralized, pulling the data, but someone who's providing the data across different exchanges, they could still manipulate the data, right? So these are the two. And then I have more on the decentralization bit.
So yeah, there's two things. The first one is that, but if tough luck, you have a very decentralized network, but they're all fetching the price from Binance. Binance, at the end of the day, is a centralized entity. Whatever transactions happen in Binance don't actually happen on the network. It's just an updating of your data center. And they could just manually override the API, provide a very false price. For example, one Bitcoin is $10. Everyone using Chainlink or any Oracle would be liquidated because they would be the ones to buy it back. And then they could sell it for the real price because no one thinks Bitcoin is $10. So yes, it's a trusted entity and there's pretty much nothing you can do about it that they can manipulate the price and with no consequences apart from legal ones. But then that's back to a banking system where we're trusting it to not do the wrong thing. And the second point you made was very interesting with market making, because you can manipulate the price through buy and sell orders, even on Hyperliquid, for example, where you are actually sending transactions. So this is an interesting one because it's also what Dennis from Egra asked me after my speech. So imagine two friends have a lot of money. One of them is participating in the Oracle game and has $1 million. And basically they agree that the first friend is going to screw the Oracle, lose the $1 million. Let's assume the Oracle's pretty good, so he's going to lose that $1 million. But the other one has now $5 million to profit from the screwed Oracle. So how do you go against this? Because basically you're limited by the liquidity that's participating in the Oracle game. If this liquidity doesn't represent the whole liquidity of Bitcoin trading, which is impossible, then it's easier to manipulate this Oracle than it will be to manipulate the market. Manipulating the market, you can't do anything against it either way. So, I mean, at least it's another subject. So how do you deal with this case? One fundamental property that me and Yonatan believe should be in any Oracle and has not been studied at all is that if you create a SKU of $5 in the Oracle game, so if you create a SKU of some certain value, and so essentially you're going to be able to profit linearly from this false Oracle price, because maybe it takes you $1 or $2 million to compensate this and exploit the arbitrage, but it's linear. Any profit you can make is linear. So if you manage to make it such that the in-game loss is quadratic in this SKU, then now you have orders of magnitude more to lose by creating this SKU in the game than what you can profit after you've manipulated it. So basically, more intuitive way to say it is, for the first player to lose $1 million, they will have created a SKU that is so small that there is not more than $1 million to profit, and even there is probably just 100K to profit. So, that's a fundamental property that doesn't exist and that should, and it can be done.
Yeah, it's massive. Like, I guess the analogy that comes to my mind is, in a traditional financial system, we've got entities that do nefarious things, and then they get slapped on the wrist with tiny fines. So what you're saying is, if you do try to manipulate certain oracles in this example, you actually are liable in a proper way. And in this case, you're saying quadratic, right?
So it means, if you create a SKU of epsilon, then your loss is going to be epsilon squared. So
right.
So basically, there is no way to, like, you will be at a loss if you try to manipulate it. Your profit function will be negative. So you don't need to rely on trust or on legal systems to slap you on the wrist. You're slapping yourself on the wrist by doing it.
Yeah, that's cool. And while you were talking, one thing stood out to me was, when we were discussing nodes, and the point, perhaps one of the first points I mentioned is, like, even if you have 100 nodes, right? In Chainlink's example, I believe they only have like 90 nodes, so they don't have a lot of nodes. But even if you have 90 nodes, if they're accessing the data from the same source, so let's say in this case they're accessing from Binance the price of Kaspa, the leader of that round on Chainlink, does it know the source for all the nodes, or it doesn't care, or it doesn't know the source?
Yeah, it doesn't. So that's the whole thing. Nodes are giving a price, but there is no cryptographic way to verify where the price came from, which is because Binance is not going to create a private key and sign everything.
I see.
Your aggregating price, you don't know where it comes from. Each of these nodes, which is, by the way, for a certain price feed, it's more 19 than it is 90. Even
Really?
for Binance, even for Bitcoin price feeds, it's more in the order of 20 nodes. It's
Right.
very, very little. And it's permission, so you can't just like these are nodes they know. Not everyone can just participate. So you don't know what you're aggregating, basically, which is the problem. Because everyone could be fetching from Binance. They could be coming up with their own price. There would be legal consequences, but that's it. Your Oracle cannot, apart from a social consensus, it cannot determine who is lying. And the median is a bad model because it relies on the assumption that 50% of your nodes are going to be honest with the data they provide, which itself is not true. I mean, it's not like in Bitcoin. So this assumption is made for consensus mechanisms, and the way they try to market it is essentially it's the same thing, right? We can take this assumption because everyone's taking this assumption, but it isn't the same thing, because in Bitcoin you have deterministic rules, or in Ethereum, if you break the rules, you're going to be slashed. The consensus is deterministic. In an Oracle game, you don't know if someone is lying. You say you believe someone is lying. Is it intentional, or is it just an error of observation because they went on a smaller exchange? If it's an error, do you want to penalize someone for taking a price which you don't agree with, because you think they're lying? Like, this is very tough, because you don't know what's happening. You don't know the prices people are giving you. You don't know if they're honest. You don't know if they have observation errors, and you're assuming 50% are honest, which is why the median should lie in between these honest votes. At least it'll be between the lowest honest player and the highest honest player. But these honest players, they don't. You don't know if someone's being honest.
Yeah. And that leads me to my other two concerns on the Chainlink model, right? And I want to get into then later on sort of the solution that you're thinking. Just briefly talk about the solution also. But the other two issues that perhaps we haven't talked about. The first one is the node collusion, right? And I think it's the part that I think a lot of people do discuss, that nodes could be incentivized to collude, right? And in fact, there's a term in the industry called Oracle Extractable value, similar to MEV, but specific to oracles in that case, right? So nodes could collude. And the fourth one, which I think is the biggest issue for me, and perhaps the one you're highlighting here, is if everything comes down to Oracle, and everything comes down to Chainlink in this example, then we're back to that centralized place, right? Then we have a single source of failure here, which we're trying to get away from in a blockchain, right? These are the two issues. Collusion and the centralization is really added by the Chainlink model, I think.
Yeah. So, the central point of failure, I agree, which is pretty concerning when you're building DeFi and when you're securing millions, to have a single person who could censor the Oracle price, render it slow, or even just give a false report. That is one area where Kaspa has a good advantage, is the parallel the multi-leader consensus. So if you manage to have several people pushing the price on chain, censoring no longer becomes viable. And the other one with collusion is very interesting because, yeah, the median. So the way the median function, when you play the Oracle game, you essentially have to pay some money to stake some money to play, because there has to be consequences for you lying. There has to be a way to slash you. The median is going to reward the players based on their distribution around the median. So reward the closest ones. But it doesn't have any idea, and it doesn't have any consciousness of what the median is. So basically, if there's a distribution around $1 and players are rewarded based on who's closest, the reward, the in-game reward, is the same as if this median was manipulated by collusion, is now around $100, but around these $100, it's the same normal distribution. So you still get rewards. You can get rewarded from being blatantly wrong and clearly lying, and everyone can get rewarded. You're just closest from the median. So
Yeah.
collusion is very simple in the median case, because I could just go around, say I have enough money, go to these 20 nodes that are giving the price from Chainlink for Bitcoin, tell them that if they all decide that Bitcoin is $10, then I will give them 500K each. So now I have a cost to create this arbitrage, of course, but they're going to collude. It's not that expensive because I only need 10 of them to lie, and they don't get slashed because the Oracle itself is not seeing this. It doesn't understand that the Oracle is being blatantly manipulated. And yeah, that's a problem with the Oracle. And I think the idea of how to detect this, there have been different ideas, and these are ideas. I'll give you two of them right now, and you'll tell me what you think about them.
Yep.
The first one is Pyth network. Pyth network. Once, if we believe the data has been manipulated, what we do is we take 3 data sources from our set of nodes who gave us the price. We take 3 of them, and we say that the median of these 3 is the real price. So now you've gone from trusting 100 nodes maybe to 3 nodes.
3 nodes, yeah.
Which is, it doesn't make any sense. Imagine these 3 nodes were part of the collusion. So the second one is a permissionless oracle called Flare Network, which is pretty big. And basically they made the Oracle part of their layer 1 blockchain, which is kind of similar to what we would like to do. And now I had a discussion with one of their PhDs on Twitter and their founder. And the discussion ended with the founder saying, as a participant in the layer 1 game, I will not manipulate the Oracle, because if I do, even if I'm not slashed by the Oracle mechanism itself, I manipulated the data so people lose trust in the Oracle and the L1 token falls in price. So this is the security argument from the founder of why the Oracle is secure, which makes no sense. And my whole debate with even the PhD was saying that you said a lot of things in your paper, but you proved them nowhere. It's like, it's crazy to think that you have a PhD, your whole education is when you make a claim, you prove it, and there are no proofs. And the arguments were, yes, but they should behave this way, or this attack is tough to carry out. And so, yeah, the pretty funny thing is when the founder answered, I took a screenshot and sent it to Yonatan and said, do I consider this debate as did I win this debate? And he said, no rhetorical questions allowed. And then I said, okay, I'll consider this a 1-0 for me.
Oh, that's beautiful. I love it. Awesome. So did you go back to the PhD guy from the Player Network?
Yeah, I tried to initiate the discussion again with a post, but they didn't answer. So, I mean, at this point, I'll just consider that I'll do my thing.
And just going to add a point there, though, I don't see how the price of the token will be affected by this action by a node. If a node tries to manipulate the data for a specific data feed, sending it to a blockchain, how would that affect or impact the price of the token? I don't know how the correlation works. That's crazy even to think that this person is adding that bit onto the argument, which makes no sense to me.
Yeah, I agree. And this is where you realize there's a problem, because these are claims that are not backed, that are not rigorous, and it's a shame to see that these oracles secure so much money, and this is real people's money. You shouldn't just try to rush a solution. It's not the way to go. If you have at least a bit of moral conscience, like if moral compass, and yeah, it's like the most basic thing is when you model the payoff, the utility function of a player, you agree that you need a term that says the more the oracle is wrong, the more money I should make, right? This is because if the oracle is wrong, you have off-chain profit to make. And every single white paper I have read does not incorporate this term in the strategy, in the optimal strategy of a player. They only say, okay, optimal strategy is to be close from the median. Everyone should be probably honest. So the median will be being honest is my best shot. But they don't incorporate this term that if the oracle is wrong, you make money. So this has to be taken into account into the strategy of any player. And this isn't in the papers, which is concerning. It's sad to see.
And how many months you've been on this journey so far?
So the first white papers I looked at was back when I was doing my thesis with Yonatan. The idea was, how do oracles currently work? What's the consensus which is using the median? Then looking at academic papers. Then designing a solution that theoretically my solution worked better under the assumption that 50% are honest. What I was saying is the median doesn't work when you're using 50%. It's too easy to manipulate. Let's make something that's harder to manipulate. So that I did, but the problem is you're still relying on the underlying assumption that 50% are honest, which is not a good assumption. And after that, when I got my grant from the KEF Foundation, the idea was, okay, let's put aside oracles a bit for now. Let's understand what is the price of an asset. How do limit order books work? Come back to the basics. Understand, okay, what does Chainlink really do? What do these? And so this is when I read the Flare white paper. Pyth also I had already read, but went more in depth in understanding how they work and where is the flawed assumption, where's the problem. So I think I've read like quite a few, about 10, until I understood that I was not going to learn anything from these. And then the idea was more, okay, let's concentrate on limit order books. Hyperliquid, how does it work? How are assets traded? How do I manipulate price? Because these are all essential to an oracle. An oracle is trying to determine what is the fair value. And market makers also have to determine this fair value to quote around. So then my focus shifted a bit to that. And then in the 2 last months, I had an idea for the oracle game, which I briefly talked about in Berlin. And I've been working on that for a bit. But yeah, it kind of depends on not my mood, but just where do I feel like something's bothering me at this time, and then I can spend maybe a month on limit order books, on oracles, reading white papers. But yeah, I don't read white papers anymore. I just have come to the conclusion that this is not where I'm going to learn, and where I'm going to learn is academia, but not oracles.
Yeah. A simple question someone might ask: why can't we just pull the price from the decentralized exchanges? At least we can, we can all agree that decentralized exchanges, your traditional market makers are not providing them the price, right, is decided on the market itself, which is what you're referring to, the order book style exchanges, decentralized exchanges. So why can't we just use them in a very simple way, if you happen to know?
Yeah, so this is a good point. If everyone was using a decentralized exchange, like Hyperliquid, for example, I'm not a fan of AMMs, but let's say everyone was using decentralized limit order books, where you have actual proof of the transactions that are taking place, the orders are actual orders, etc. Then you would have, it would be much better if it was just one Hyperliquid. There would be no need for an oracle, just like in traditional finance there is no need for an oracle. But right now you can't use that model because it's undeniable that a majority of trading happens on Binance. So you can't just ignore this. It would mean that you're essentially saying, okay, if you want to manipulate an oracle, you only need to manipulate dexes, which is easier than manipulating the whole price across exchanges. But yeah, it was an idea I had, but it's just not realistic, and I don't think it will be a thing.
No, I think I wanted to highlight that bit, that it's that's the ideal world we all want to live in. But unfortunately, when you have 90% trading volume goes through the exchanges, dexes are very, very tiny. And in fact, dexes are the ones that are catching up to the price, right? So the centralized exchanges will set the prices, right? And then the arbitrageurs will jump onto the decentralized exchange to repick the price to whatever the price, the market price, centralized exchanges are quoting. So sort of work backwards. And that means you are sort of in this weird limbo if you were trying to just pull the price from the decentralized exchange, right? That you can't rely on just those. You have to take cumulative data from all the places.
Yeah. If you want your oracle to be difficult to manipulate, you need to encompass. I mean, the goal is to have a global price. So you can't have a global price by ignoring whatever's going on in centralized exchanges.
Yeah. So Elliot, what are the solutions / areas you're looking at, right? I know you've talked about TEEs, these trusted execution environments, oracles. So what are the areas that are sort of focus areas for you now, and the direction it's going in?
So TEEs I find are good as a temporary solution before having an oracle designed in the layer 1. Why is because at least with TEEs, you have the guarantee that the data you fetched has not been tampered with. This doesn't mean that the data itself, that the data source is good. You could still have the problem we talked about with everyone fetching from Binance, but at least you have the guarantee that the data was not tampered. So I think this is a good replacement for if you don't have a big node network like Chainlink. You don't want to trust a single person to get the price from several APIs. So you could have just a single person, but using a TEE, which means that he can't manipulate it. He can't just say ridiculous stuff, but at the same time, he could just create, I could create a fake API. So just a website with a terrible API, which I control and have, I can write whatever. And my TEE will go get the price from that data source and will say, everything's good. We got the price as intended. So it's a good tool, but it's not a solution. And what's good is Quex, for example, they don't claim it's a solution, but it is a very good tool. Now, Um, a better, not a better, but an actual solution. So would be designing a game where you have to be honest, which I touched upon in Berlin. My idea is to recreate an order book in the sense that if you give a price to the oracle, so imagine I'm saying Bitcoin is $1 million. I'm lying. The idea is put your money where your mouth is. If you say Bitcoin is $1 million, then anyone selling below $1 million, you should be willing to buy, right? You're going to make a profit if you think the price is $1 million. So basically, the way I see it, imagine you give a price to the oracle, then anything below this price, you should be willing to buy. And the further you are below, the more you should be willing to buy. And anything that's above, you should be willing to sell. And the higher, the better. So the game is when I give a price, my stake is used to create these symmetric buy and sell orders below and above my price. And then we make a trading game. So everyone gives a price. There's a lot of buy and sell orders. And then you exchange the asset based on who said what. So now imagine that I'm lying. I'm saying, yeah, Bitcoin is $1 million. Then I have a lot of buy orders below $1 million. If everyone else is honest and everyone says Bitcoin is 100K, they have a lot of sell orders above. So I am going to be forced to buy everything from them. And the little subtlety is at my price. So if I said I'm willing to buy at 900K, I will be buying at 900K. Which is now you have to be careful what price you're giving because you're going to be forced to buy and sell. So you should be at least a little bit honest.
I was going to say, that's very interesting. But I think from a practicality point of view, how would it actually work? Because if you are running this order book style exchange, decentralized exchange, you are not the one with the liquidity, right? You are not the one that is going to buy and sell, because that buy and sell, then you're getting into the market maker mechanics here, right? That's the job of a market maker, right? Or liquidity providers, we can call them, probably better term. So how would that work? Because this is the protocol that's running the DEX, order book DEX. But the actual order is actually being implemented by institution, market maker, or the retail, right? Those are the three players in the game. So how would, I'm trying to connect the price of the oracle to the liquidity events that you're mentioning?
Yeah. So the participants in the game are the miners. They're not anyone. It's permissionless, but you have to run a miner. You have to be part of the network. So yeah, as I said, this is pretty funny because I'm not sure how the software would work. Yonatan told me concentrate on the game itself, trying to solve it. And I'm very much looking forward to see how this can make sense implemented on a miner network. Because it's pretty blurry for me.
No, I think this is great. That's why we have this discussion on XXIM podcast, to have the builders express themselves. And it's amazing to hear that's the direction you're going in. Of course, it's going to get clearer for you over time as you spend more time, right? It's been an amazing discussion and I enjoyed every second of it. I wanted to ask you though, to wrap this session up, what's the big vision for Yonatan for oracles? Do you have his grand vision that he thinks about what an oracle acts and should look like?
I think the vision is in the foundation the same as Kaspa. You have to, if you want to build DeFi, if you want to secure people's funds, you need to have something that is mathematically proven to be perfect. I want the oracle I'm designing to be perfect. There is no, but how can you manipulate? No, it'll be, if you manipulate, you lose. The optimal strategy has to be being honest. And then I think the way he sees it, and I also see it, is you need to, if you design an environment where, say, MEV, for example, users are not going to get MEV'd on Kaspa. Users are not going to lose funds from Oracle manipulations on Kaspa. Then this should attract liquidity. It should attract people, because you're creating an environment where just every bad possible outcome doesn't exist for you. So as a market maker, as a retail trader, you should want to come on Kaspa. So yeah, the way I see it is on the long run, like sucking up the liquidity from other platforms which are losing a lot of money for their users, getting MEV'd, getting Oracle exploits.